Administrative distance. In this video, I'm going to talk about administrative distance in the first section. After that, we will talk about the static routes. You know that in IPv4 routing and also in the IPv6 routing, we have multiple sources of the routing information. For example, in one router, the routes that are available in the routing table may be learned from the connected interface, may be learned from the static route, and also may be learned from the routing protocols. And each of these methods can be used for populating the routing tables. In some cases, we are more than one source of information. For example, assume that in this scenario, in this part, we have R1 and R4, and here we have two routing protocol. The first is RIP, the second is EIGRP, and now the R1 is learning the network, for example, Quad 4 from both RIP and EIGRP. Which one should be used? In this scenario, we have only one pass, but in some scenarios, we have more than one pass, and each of these two routing protocols maybe choose another and different pass. Which one is better? RIP is better or EIGRP is better? Here we have a problem. The problem is that when we are receiving the routing information from more than one routing protocol, which one is better and which one should be entered, should be injected into the routing tables? The answer of this question related to the administrative distance. Actually, in the routing, we have one number, one value for each source of routing information, and the name of this value is administrative distance. Administrative distance can be a value between the 0 to 255, and when one routing protocol has lower value of the administrative distance, that routing protocol, the source of routing information is assuming the better source. For example, assume that here between the RIP and EIGRP, RIP has the administrative distance of 120, and EIGRP internal has administrative distance of 90. This means that EIGRP's information, EIGRP's choose, is better than the RIP because the administrative distance of the EIGRP is lower than the RIP administrative distance. Don't forget, when we are we have a tie between two routing protocols, we are using the administrative distance. For example, here in the link between the router 1 and router 2, we have only OSPF. Because of that, in router 1 we will learn only from the OSPF the routes, for example, Quad 2/32. Because of that, here the administrative distance should not work because here we have only the OSPF. But in some cases, you are encountering with this condition that two or more than two routing source are giving us the information about one route. Because of that, we are using the administrative distance to understanding which source is more believable, and which source is a better source. Also, let me to emphasize that the default value of these methods are the numbers that we have in this table. If you want, you can change these values, but in most cases, the default value is the good choice. For example, about the connected interface, the administrative distance is 0. This means that when we have one connected network, for example, here on the router 1, 10.0.0.0/13, this is the more preferred method. Why? Because the administrative distance of 0 is lower than other routing protocols. Also about the static route, because the administrator itself is configuring the static route, here we have the administrative distance of 1, and you know that this is for example, high preference value. About the EIGRP summary route, we have the administrative distance of 5. You didn't learn about the EIGRP summary route in this class. In the future videos, you will learn about the EIGRP summary route. Because of that, don't worry, you will learn the EIGRP summary route in the NRC. After that, about the EBGP or external border gateway protocol, the ADs 20, you will learn about the EBGP in this class. Also about the EIGRP internal that has the administrative distance of 90, you will learn in this class. About the OSPF, you have learned before in the CCNA class, and also in the NRC. Again, you will hear about the OSPF, and you will learn more than OSPF more than CCNA related to the OSPF. Because of that, the OSPF administrative distance is 110. After that, we have another routing protocol, the ISIS or intermediate system to intermediate system. ISIS has the administrative distance of 150. You will learn about the ISIS in higher courses. After that, about the RIP or routing information protocol has the administrative distance of 120, and you know that this is not a strong protocol, and maybe you encounter with this protocol in other courses. About the ODR or on-demand routing, we have the administrative distance of 116, and you will learn about it in future courses. About the EIGRP external, you will learn in this class, okay? The administrative distance of external EIGRP is 170. And also about the IBGP or internal border gateway protocol, again, you will learn in this class in the NRC, and the administrative distance of the IBGP is 200. Also, if we want to don't use one source of routing information, we can configure the administrative distance of that source to 255, the highest value. And when one routing information source has the administrative distance of 255, means that this route should not be used, and this is not believable, okay? This is unknown route. Because of that, if one source of routing information has the AD of 255, this means that that route cannot be used in the routing table. This is the overall, or this is the generic or default values of the ADs. You can change some of these values. For example, for EIGRP, you can change the administrative distance. For OSPF also you can change. For EBGP and also IBGP, you can change the administrative distance. And after that, for the ISIS and RIP also you can change the administrative distance. But in most cases, we don't need to change the default administrative distance. Here we have a simple scenario. This scenario is only for verifying the administrative distance. I'm not going to talk about the configuration of the RIP and EIGRP. I will show you the configuration, but you will learn about the EIGRP in this class, and my goal only is showing you the administrative distance. Because of that, I'm going to use one notepad file for configuration. The detail of configuration at all is not important at all. Because of that, only we should notice to the for example, the administrative distance, not the other things such as the configuration. Look at here, I'm going to configure with the notepad file in R1. As you can see, we have three interface: enable, conft, interface. Okay, I'm going to use the interface command, then fast ethernet 00 IP address. Okay, the IP address of the fast ethernet 00 is 10.0.1.255.255.255.252. Look at here. In this example, for the interface on the router 1, I am using the lower value. For example, here I am using 10.0.0.1/30. On the fast ethernet 01, I am going to use 10.0.0.5. In the fast ethernet 10, 10.0.0.9. Okay, let me to show you. Here, IP address 10.0.0.1.255.255.255.252. Then no shutdown. That's it. This is the interface fast ethernet 00. Let me to configure to next interface fast ethernet 01 and fast ethernet 10. About the fast ethernet 01 is the IP address is 10.0.0.5, mask is 255.255.255.252, and then no shutdown. About the fast ethernet 10, the IP address is 10.0.0.9, 255.255.252, and then no shutdown. That's it. And about the configuration of router 2, let me to copy this part This is the configuration of router 2 for IP addressing. Router 2. Here we have the fast Ethernet 00 interface, and the IP address of this interface is 10.0.02.255.255.252, no shutdown. Also, we have one loopback interface. Let me to configure the loopback interface